Okay, fine.
Cool.
That's fine, bro.
Okay, so I guess we have started. Okay, so what we will do today is we will learn some techniques. Okay, we'll learn some techniques and probably like before going into each one of them, and we'll also have a discussion on DP on trees. And maybe first, before discussing anything, I guess we should again see DFS one, right? Because
Yes, yes.
we were a little bit confused in the last class,
Yes.
right? Okay, so if you remember, we had couple of questions to solve. That what is the depth, what is the subtree size, parent, number of child. Do you remember that, Sam?
Yeah, yes, yes.
Right?
Yeah.
Okay. So what we have to do is like we had to calculate each one of them, right? And let me open OneNote also. Okay, it's batch counted. Sorry. Yep. Yeah. So Sam, you remember we were discussing about this tree in the
Yes.
last class, right?
Yeah, yeah.
So what we had to do is we were given a tree, okay, something like this, okay, something like this. And what we had to calculate is for each node, couple of parameters which we discussed, right?
Yeah, yeah.
Yeah. So what were those parameters? Those parameters are we have to tell whether it's a leaf or not, what's the depth, what's the subtree size, parent, number of child, right? So
Yes.
so you know the terminology for each of the terms, right? So just to be clear, can you tell the subtree size of this node? I mean rooted here.
4.
Yes. So you're clear, right? And I guess
Yes.
remaining are pretty easy.
Yeah, yeah, clear, bro.
Yeah. Okay. So what we did was we randomly chose one arbitrary node, okay, and we made it as root. So in in most of the problems, what we will do is we will make node zero as root, okay, and from here we will do DFS. Okay, what happens in DFS? In DFS, first you will go here, you will come back again, you will go come back, start iterating, right? This is what we do in DFS, right?
Yes.
Go to depth as much as possible. When you don't have the possibility to explore any other nodes, you just come back via recursion, right? And
Yes.
the time complexity for this is big of n itself, okay? So it's no harm doing a DFS and finding out all the parameters. So if you see on that day, we have done some kind of calculations, okay? So remember this point, Sam, is that in DFS, whenever you write a DFS, right, you can pass as many parameters as possible. Okay.
Yeah.
Okay. So in our case, what we have passed is, see, node is needed, its parent is needed, and we also maintain something as depth, which will tell me at which depth we are. Okay.
Yeah.
Okay.
Hmm.
So what we have done is we have taken the depth parent, we just initialized with whatever the values which we have, and
Hmm.
initially subtree size will be 1, right? Because that is that node. So that
Yes.
node will have size 1. Then
Yeah.
what we will do is we will iterate on each of the neighbors, okay? We will iterate on each of the neighbors, and you remember we discussed for this guy, for this node, the neighbors are this one and this
Fair.
one, but
Yes.
we don't want to visit this node, right?
Yes.
Because this is the parent. So that's the reason, if you see, we have written if it is not a parent, then only go ahead with the DFS. Okay.
Okay.
Okay. And then
Okay.
as soon as we return, what we do is we calculate its subtree size, the neighbor subtree size. Because
Okay.
for this node, if there are something like this, okay, let's say like this, the subtree size is 3, right? For this
Hmm.
node,
Yes, yes.
and the subtree size is 1 for this
1.
node, right? So this will be nothing but 1 we already have
Yeah.
plus 3 plus 1, right? Which is 5. True.
3 plus 1. Yeah.
3 is
Yeah.
this one, one is this one, and this one is itself.
Yes.
So if you see, we have done the same thing, right? What we have done is, for the current tree, we have taken its child. Neighbor means child, okay?
Yeah.
And since we know that it is not a parent, we are increasing the child nodes, okay?
Yeah. Yeah.
Finally, in order to calculate whether it is leaf or not, we know, right, what's the definition of
Yes. Yes.
the
Yeah.
one which does not have any children. So if it
Mm.
is 0, that means it is a leaf, otherwise it is not a leaf, okay?
Okay.
And let's take a random example maybe, and we can try to see whether it's...
Like actually, last time also we did the same thing, right?
Yes, last time, no, actually the problem was here.
What was
uh, this one.
edges size?
So
You
what I can do is I can make it like this, okay? And this one I should make it n minus 1 probably. Edges, you know, right? How many edges will
yeah.
be there in a tree? N minus 1.
Yes. Yeah.
It was n. So what happened, you know? There was
Mm.
one extra zero got added. That's the reason. It was not working.
Mm-hmm.
And one more thing, in the function also you have changed the order, right?
Which order?
This subtree size of current node plus equals to this one. In the session you have written up to the DFS.
Is it?
Yes, yes.
No. How it can be true? I cannot write that. Like, where did you see that? I mean, how can I verify whether that's what I have written?
I have seen the videos, bro, in the YouTube. That's I have compared like two codes, which you have shared in the WhatsApp and that code. I have observed two changes: that loop and this one.
Okay, maybe I can check the video again, but for sure I don't write those kind of code, because I know that after DFS only it will be available. But again,
Mhm.
let's ensure that. But yeah, leaving forgetting all those, okay, we will follow this order, okay? And
Yeah.
after DFS only, our uh, child's answer will be ready every time, okay?
Okay.
Cool. So what we do is, probably we can take this example and maybe let's try to run, okay? And let's see uh, whether we are getting correct answer or not, okay? There are 6 nodes, right? So
Yes.
there are 6 nodes, and there will be how many? 5 edges. 0,
Fine.
0, 2, 0, 3. You see, we have 2, 5. Okay. So now if you see node 0, okay,
Leaf
leaf
also.
false. That is, it is not leaf. Depth is 0. Okay. What is the subtree size? 6. So do we have a subtree size of 6 for this node? 1, 2, 3, 4, 5, 6, right?
Every node. Yes.
Yeah. So it is 6. Parent is -1, because obviously there won't be any parent for root node, right? And there are 3 childrens. Agree? 3 childrens.
Yes. One, two, three.
Yeah. Similarly, for the node 1 also, is it leaf? Now you see that it's leaf. That's the reason we got the value as true. Okay. And depth is 1, subtree size is 1, parent is 0, number of children are 0, right? And probably can see that all of them are being populated properly, right? Okay. So any question so far? I mean, this is the previous session's code only, right? So
Yes. Yes.
I guess
Fine.
everything should be fine till here, right? So tree का question आया, this should be in your on your mind, right? Very simple. Check if it is not parent, make a DFS call. That's all. Nothing else. Okay. चलो ठीक है, clear, right, everyone?
Yes, bro.
Yeah.